SNS College of Technology Department of Civil Engineering Torsion of circular shaft TS by Dr. K. Arumugam. A bar subjected to moment in a plane perpendicular to the longitudinal axis, i.e., in the plane of cross section of the member, is said to be in torsion. This moment is called twisting moment or torque. Torque equals T unit, Nm, kilonewton m, etc. T axis of shaft. A member is said to be in pure torsion when its cross sections are subjected to only torsional moments, or torque, and not accompanied by axial forces and bending moment. Consider the section of shaft under pure torsion. The internal forces develop to counteract the torque. At any element, the force dF developed is in the direction normal to radial direction. This force is obviously shearing force and thus the elements are in pure shear. If δ is the area of the element at a distance r from the axis of the shaft, then assumptions in the theory of pure torsion: the material is homogeneous, isotropic in Lebesgue-Hooke's law, stresses are within elastic limit, i.e., shear stress is proportional to shear strain. Cross-sections which are plane before applying twisting moment remain plane even after the application of twisting moment, i.e., no warping takes place. Radial lines remain radial even after applying torque, i.e., circular sections remain circular. The twist along the shaft is uniform. Shaft is subjected to pure torsion. When a circular shaft is subjected to torsion, shear stresses are set up in the material of the shaft. To determine the magnitude of shear stress at any point on the shaft, consider a circular shaft of length L, fixed at one end and subjected to a torque T at the other end as shown. The line AB rotates by an angle phi and the point B shifts to point BL, when the free end rotates by an angle theta due to the applied torque T. R equals radius of the shaft, m, g equals modulus of rigidity, n/m2, theta equals angle of twist, radians, L equals length of the shaft. M, where Zp equals Jr equals polar modulus, where tau is maximum shear stress, occurring at surface, and r is extreme fiber distance from center. Thus polar modulus is the ratio of polar moment of inertia to extreme radial distance of the fiber from the center. Unit, m3. Torsional rigidity, or stiffness. Torsional stiffness is the amount of torque required to produce unit twist. Thus the term Gj may be looked as torque required to produce unit angle of twist in unit length and is called as torsional rigidity or stiffness of shaft. Unit, Nm2. Power transmitted by shafts. Consider a shaft subjected to torque T and rotating it in revolutions per minute, RPM. Taking second as the unit of time, angle through which shaft moves equals n times 2 pi 60 power, P equals work done per second.